Today we will discuss about the basic principle of a refrigerator. So before discussing the basic principle of the refrigerator, we should know what is the purpose of a refrigerator. The purpose of the refrigerator is to keep the food items for considerable period of time. And in refrigerator, a body or space is maintained at a temperature much lower than the atmospheric temperature. So at low temperature, the bacteria, they find it very difficult to survive, or at least their effect on food items is significantly reduced. But all of us know that heat spontaneously flows from a body at high temperature to a body at low temperature. But heat can be made to flow from a low temperature body to a high temperature body when some work is spent upon the system. Let me show the block diagram of a refrigerator. This is atmosphere which is maintained at temperature T1, and this is the body or the refrigerator which is maintained at temperature T2. T1 is greater than T2. So this one is your refrigerator. Q2 is the amount of heat that is extracted from low temperature body, and Q1 is the amount of heat that is delivered to the high temperature body, and W net is the amount of net work input given to the refrigerator. From law of conservation of energy, the amount of heat that is given to the atmosphere is the summation of the heat that is extracted from the low temperature body plus the net work input that is given to the system. Now actually we will consider the schematic diagram of the refrigeration cycle to understand how the system is actually executed. So here also we have the atmosphere which is maintained at temperature T1, and this is the body that is maintained at temperature T2. Then we do have 4 components which put together perform the function. Now the 4 essential components of the refrigerator are your evaporator, your compressor, your condenser and your expander. Refrigerator employs a working substance called your refrigerant. Refrigerant flows through all the components, and refrigerant actually helps in carrying the heat from the low temperature body, that is the refrigerator, to the high temperature body, that is atmosphere. So let us consider the entry to the compressor to be 0.1. This is a convention that we have taken. We can choose anything as 0.1. You can consider this as 0.1, you can consider this as 0.1, you can consider this as 0.1. There is no hard and fast rule, but for our convenience we have considered the condition of the refrigerant at entry to the compressor as 0.1. So here actually what happens, the refrigerant enters the evaporator, and in the evaporator it receives heat from the medium to be cooled, and Q2 is the amount of heat that is transferred from the body that is to be maintained at low temperature to the refrigerant. Then this refrigerant enters the compressor. In the compressor, this refrigerant is compressed, and due to compression there is a significant increase in its temperature. After that, the refrigerant is taken to the condenser. In the condenser, it delivers heat to the surrounding condensing medium and gets cooled. After that, it enters the expander. In the expander, it expands, and you know that the process of expansion is just the reverse process as that of compression. So when it actually expands means definitely its pressure drops and temperature also drops. So the low pressure, low temperature refrigerant enters the evaporator to start a new cycle. And you know that compressor is a power consuming device. So WC is the amount of work input that is given in the compressor, and your expander is a work developing or power developing device. So net work input W net is the difference between the work input that is given to the compressor minus the work output we get in the expander. The refrigerator is also known as a latent heat pump because it pumps the latent heat. It extracts the heat from the body which is to be maintained at low temperature, mostly in form of latent heat, and it delivers heat to the surrounding condensing medium which is your atmosphere, again delivering the latent heat. The components compressor and your expander, they work as facilitators. That means the compressor helps in the condensation process and the expander helps in the evaporation process. The performance of any system is always important, and the performance parameter of the refrigerator is known as your coefficient of performance or COP. This coefficient of performance or COP is analogous to the efficiency of a heat engine, but not necessarily the same as the efficiency, but it is similar. This coefficient of performance is the ratio between the desired effect divided by W net. So desired effect is actually extraction of Q2 amount of heat from the body which is to be maintained at low temperature. And W net, as you know, is the difference between the work input given in the to the compressor minus the work output obtained in the expander. Higher the value of COP, the better proficient the refrigerator is.